Chapter 16 is about confidence intervals. So we're going to start getting into the nuts and bolts of how we do statistics now that we have a good understanding of how to collect good data and how we are allowed to make inferences or not allowed to make inferences based on how we collected that data. But before we get into exactly how we conduct a confidence interval, I have a question for you. So in the original UNO deck, how many cards are there? Do you have a guess in mind? Okay, I want you to refine that guess a little bit. So in your mind, you probably have a guess of a certain number. I want you to change that guess to be a range of values. So do you think it's between 22 and 37 cards? Is it between 200 and 450 cards? So I want you to think of a range of values that you think contains the true number of cards in a deck of UNO cards. Okay. That range of values that you just thought of is a confidence interval. So a confidence interval is a range of values that we think somewhere within there is the true number, the correct number of cards in that UNO deck. It might be in the middle, it might be more towards one end or towards the other end, but somewhere within there we think is the true value or the exact value that we're looking for. Okay, before I tell you what the true number is, I have 4 more questions for you to think about and to create some more confidence intervals for. So next question, the first item ever sold on eBay was a broken laser pointer. In dollars, how much do you think it's sold for? So looking for a range of values again. How many times did Ron's name appear in all 8 of the Harry Potter books? So again, range of values. In miles, how long is the main part of the Great Wall of China, excluding all the little secondary branches? And the last question, confidence interval for how many states were part of the United States in 1860? So range of values that would include how many states were part of the US in 1860. Okay, so you've created 5 confidence intervals for us. Let's see how many of them contain the true values. So the number of cards in an UNO deck, in the original UNO, is 108. The broken laser pointer sold for $14. The number of times Ron's name appeared in Harry Potter was 5,784. The Great Wall of China, the main part, is 4,163 miles long. And in 1860, 33 states were part of the United States. Okay, so I hope that you got at least one of those intervals correct, contain the true value. So let's go ahead and look at our first type of confidence interval. This is a 1 mean z interval. Okay, so our goal here is to find a confidence interval for the population mean mu. So we're looking for a range of values that's going to contain the true mean or the true population mean. Okay, there are a number of different confidence intervals that we can make. We can do ones that have compare 2 different means or look at the difference between means or a proportion. But we're going to start out with the most basic one, which is a 1 mean z interval. And I've created a mnemonic for you. It's called the panic method. And this is to help you remember all the things you need to include in the process of doing a confidence interval. So your first step, the letter P, is the parameter statement. So this is just a quick jot down of what we're going to be doing. So this is some sort of percentage. CI is for confidence interval. So maybe this is a 95% confidence interval for mean number of times Ron's name is in the Harry Potter books. Okay, so it doesn't need to be a complete sentence, but you need to mention the percentage and an idea of what mean we're finding here. All right, the A in panic is for assumptions and conditions. We have 3 things that we check. So the first one is a simple random sample. And the reason we check that is that allows us to use statistical inference to apply our results back to our population and to really use the power of statistics in our calculations. The second one, this normal population or our large sample. So this is getting at the central limit theorem. So either your original population needs to be normal or you need to have a large enough sample, meaning 30 or more. And if you don't have those conditions, then you would be using a different process or a different procedure. So these are the requirements to use this one mean z interval. If you don't have these and you can't use this process, you have to do something different. Okay, so we had that simple random sample, which is allowing us to use inference with our results. We have this normal or large enough, which is getting us the central limit theorem. And then this is the last requirement that tells us that we can use the z interval and not something else like a t interval. So this is that sigma is known. This is our population standard deviation. And this is really the one that tells us which type of interval we're doing. Right? And if the population standard deviation is known, then what we have is a z as in zebra distribution. And so the name of our process is a one mean z as in zebra interval. It has a really long name, z confidence interval for population mean. You can really just shorten that to be one mean z int. In fact, you don't even need the rest of that. I'm fine with just one mean z int. Okay, so that's the n. That is usually one free point. If you can correctly identify what it is you're doing, that should be an easy point to get in terms of score-wise. The I in panic is for the interval. And this should look really familiar. You've been doing this on almost every homework all semester long. You've been doing this calculation. The x bar is your sample mean. The sigma is your population standard deviation, and the n is your sample size. This guy here, the z star, is one whole unit. So that's not z times the sigma and the square root of n. That's z star is one whole piece. Okay, and it's called a critical value. So z star is known as a critical value, and it's related to this confidence level. So up here I said we're looking for a 95% confidence interval. So our confidence level, the most commonly used ones are 90, 95, and 99%. Your confidence level can really be anything between 0% to 100%. Like I said, these are the most commonly used ones. And with a z as in zebra distribution, these numbers stay fixed. So a 90% confidence level is always a z star of 1.645. 95% is always 1.96, and 99% is always 2.576. Okay, so that is always what the z star will be if we're doing a z distribution. Okay, we're going to talk about what these different levels mean and where these values come from a little bit later in this chapter. So we'll come back to that. Right now, I don't want to overwhelm you with a whole lot of information. I want to get you actually into using this process. All right, and then the last step here is to write a conclusion. So that C in panic is the conclusion. And your conclusion needs to include the level, the interval, and then some context. So this is a lot like in chapter 5 when we were talking about the slope and the intercept in context of the problem. There's going to be some context here. So we are blank percent confident. So if I kind of come back up here to this statement here, I'm just going to reuse this down here. So I am 95% confident that the true mean number of times Ron's name is mentioned is somewhere between, and then whatever numbers came out of this process. So you get two numbers out of here, so I would list those two numbers here. So depending on kind of how the wording is, this here is a little bit of optional wording. Okay, so sometimes you'll use this of here and sometimes you won't. It really just depends a little bit on how the wording in the problem came out. So these two blanks kind of go together in the sense that this is somehow talking about the context of the problem. This is always going to be the confidence level. This is always going to be the interval over here. And these two blanks make up the context. And so sometimes it really is just one blank, sometimes it's both of them. It's kind of however you can make the wording come out so it's not too terribly clunky. All right, so we're going to come back and look at number 1 in the next video here.